Okay. Example 2, find the values of C guaranteed by the mean value theorem for integrals, or MVTI, for the function over the indicated interval. So let's do part B just because it has a trig function and just because trig functions are fun. I like them. So we're going to set up what the formula actually says, and that was in the previous video. So the formula is the integral from a to b of your function dx, and we said it's equal to f of c times b minus a. So what we're going to do is we're going to figure out the left side. We're going to do the definite integral. So negative pi to pi of our function, which is cosine. And then over here on the right side, we're going to fill this in as well. So f of c, I'm just taking c and I'm going to plug it into the function. So cosine of c times b minus a. So pi minus negative pi. So pi plus pi. So it's a little weird because I have not yet done this definite integral. Okay, this is not f of b minus f of a. I'm going to do that, but it's all going to be on this left side. So I'm working the two sides down. So let's go ahead and integrate cosine. So the integral of cosine is sine, and I'm going from negative pi to pi. Over here on the right side of the equation, pi plus pi is 2 pi, and I'm going to move it to the front. And my cosine of c is still there. So back over here on the left, plug in the bounds. So sine of pi minus sine of negative pi. And on the right side, I can't do anything with it. It's still just 2 pi times cosine of c. Well, sine of pi, that's 0. Sine of negative pi, that's also 0. So my left side just totally goes down to 0. So once you get it to here, once you've evaluated this definite integral down to a number, and you've worked the right side down as far as you can, then you're in a position to solve for c, because that's what it told you to do. Find the values of c. So solve it. So divide the 2 pi over and go, all right, where does cosine actually equal 0? Well, that would be negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, and so on and so forth. But you only want to find numbers or values that are in this interval right here. So if they're not in there, then they're not part of the solution. So it's just negative pi over 2 and pi over 2. So there can be more than one solution. Sometimes there might only be one, but you're guaranteed to at least get one answer. Okay, so now that we've used the theorem, what does the theorem really do? So what on earth did this give us? So it finds the location of the x value that generates or gives the height of the rectangle whose area equals the area under the curve. So it would give us that one rectangle that we could draw, and it gives us the location of where it, where that height is going to be. So in our case, we have two values, so there would be two different rectangles that you could draw that would actually equal the area under the curve. Okay, so the area of the mean value rectangle, which is the same as the area under the curve, equals base times height, right? So what happens if you take the area and divide it by the base? Well, let's find out. So here's that theorem, and we're going to take the area and divide it by the base. Well, this is the base. And we're left with f of c is equal to that integral over b minus a. So what this did is that this height, that f of c, is the average value of the function over the interval from a to b. Because this, it gives you the whole area under the curve, and then when you divide it by b minus a, you're dividing by the total of things that are from b to a. When you take like a sum and divide it by how many things are in there, that's an average. So that gives us the average value of the function. And instead of writing like this one big old gigantic fraction, what they do is they put the fraction in front. So 1 over b minus a times the integral from a to b of f of x dx. Okay, so the next video we're going to look at the average value and calculate it and go from there.